Hello, everybody, and thank you for joining us for today's webinar, where you will learn how to reduce storage TCO by 4 times in under 30 minutes. My name is Adrian Herrera, but the main content in this presentation will be presented by Glenn Olson, who's the FileFly product manager. Glenn, say hi to everyone.
Hey there, everybody.
So before we begin, a little housekeeping. If you have a question at any time during the webinar, just go ahead and type it into your dialog window there on the right-hand side. If we don't get to it during the presentation, we'll answer it at the end. There'll be a short Q&A session at the end. But we do want this to be interactive, so please go ahead and ask questions wherever you feel like you have them. So with that, let's go ahead and start. First, I'm going to give a quick overview on Caringo and a quick overview on the subject matter. Caringo was founded in 2005. We've always focused on software-defined storage. We've been around for about a decade now, and we have hundreds of customers, in fact, more customers than any other object storage player on the market. We have unrivaled integration by a lot of our partners worldwide, including service providers and ISVs. We're enterprise grade. We're used by lots of governments around the world, a lot of organizations that you've heard of using us for mission critical applications, such as medical applications. And we're a recognized leader in the object storage space by a number of different analysts. One of the questions we hear often is, okay, why do you need object storage? Why do you need to do stuff differently? Well, one of the main reasons is the explosive data growth. I think if you've been around the storage world, or you've been in the IT world, you've seen all of the hockey stick diagrams that show data growth just exploding. Some of the main data points that we like to share is that 90% of the data in the world has been generated in the last 2 years, and the vast majority of this information is unstructured data. But depending on which analyst you want to believe, there's about 4.4 zettabytes in 2013, which is forecasted to increase to 44 zettabytes by 2020. It's an unfathomable amount of information. And traditional storage resources can't keep up. You have too many files. When you have too many files, file systems really have a hard time protecting billions of files. And a lot of companies that we work with have billions of files. There's wasted budget. NASs and SANs traditionally came in proprietary solutions with hardware and software combined. And because of that, there was overhead built in, additional cost built in, that just leads to wasted budget, limited reuse, and a limited risk. Files are difficult to search, analyze, and access, leading to continued use and risk. Protection. Once data sets get to be a certain size, they're very difficult to protect. Also, now that hard drives are exceeding 4 terabytes in capacity, traditional protection methods like RAID are just becoming impractical. To top this off, managing all this information, petabytes of information, billions of files, is very difficult to do. A lot of companies are using multiple solutions, and it just adds to the complexity. And of course, limited scale. NASs and SANs do have finite scale, so ultimately you need to go through a forklift upgrade or some other painful migration to a new storage solution to be able to support your data growth. And again, that's just not practical considering the amount of capacity and the amount of files that we're now seeing. So this is leading to the need for object storage. And what's object storage? Object storage falls into the broader software-defined storage market in many cases. So you're able to scale out on commodity hardware, provide end-to-end data services. Object storage is fault tolerant, and there's multiple interfaces and hardware deployment options. So that means that you're able to support not only traditional storage interfaces such as SMB, such as NFS, FTP, you're also able to support some of the new latest and greatest cloud interfaces or API-based RESTful interfaces like the Amazon S3 API or straight HTTP. There's some good data that was just released by ESG that surveyed about 300 organizations, and out of those 300 organizations, 82% said that they were either considering or have already deployed object storage. This was a significant increase from just about 2 years ago, where that number was about half. 70% say object will eliminate or significantly reduce their NAS footprint in the next 3 years. So if you're not doing this already, it's great that you're watching this webinar, because most likely your peers are already looking at object storage in one way, shape, or form. And as far as object storage goes, Caringo does provide object storage. Our object storage solution is called Swarm. I'm just going to give you a brief overview and then hand it over to Glenn to give you a demo on FileFly. But from the Swarm perspective, Swarm, Caringo's object storage solution, provides two macro functions. The first there in the magenta color is infrastructure management. So Swarm comes as a software appliance. You boot it from bare metal. It runs from RAM. It's highly efficient. It leaves 95% of the actual disk, the hard drive, for your content. Flexible deployment. You can deploy it as a private cloud solution. You can deploy it as a hybrid cloud solution. BT and Telefonica use us to provide their public cloud storage services. So it's very flexible anytime you need massively scalable storage. It supports continuous protection. Again, I won't drive down into these because this isn't a Swarm demo per se. This is a FileFly demo. But we do have a lot of information on our website that goes into these in detail. We can follow up with more if you want more information later. But we have some really good papers on continuous protection and a really good webinar on continuous protection if you're interested in that. We also offer enterprise support. This is support worldwide, and we do have proactive support. So there is a service that we offer. If we see an issue start occurring with your cluster, we will proactively reach out to you and fix it. So we do have the concept of a phone home report. On top there, you see data service enablement, and this is really how Swarm is different compared to other object storage solutions on the market. So you have universal access. We support, as I mentioned, just like a lot of other players, standard traditional storage protocols, and also the latest and greatest cloud protocols like the Amazon S3 API. But we also add search, and we add it in a way that's able to support a lot of the most popular analytics programs out there on the market, or analytics platforms out there on the market. So you can analyze your data with programs like Kibana, like Spark, and that's where you see the analyze little section there. But it always leads to the question, okay, you have this great platform, this great object storage platform. How do you easily plug object storage into your existing Filer environment? And with that, we experience this question over and over again. At first, we came out with a file emulation layer, file system emulation layer, but there was always a performance issue. It was good for very specific use cases, but if it looked like a filer and smelled like a filer, our customers ultimately tried to use it as a filer, and that just wasn't working for a lot of them. Things like renaming a directory or renaming or searching or crawling files, it became very tedious. Because of that, we came out with FileFly, and FileFly is a Windows application. It provides smart file movement based on value. So you install it, it plugs directly into your filer. You install it on a Windows server, it also plugs into your NetApp environment. It provides transparent file access, no application changes. It streamlines backup, auto tiering, and restores. And it's really meant to intelligently move information from your filer to object storage in a way that is completely transparent to your users and in a way where you do not have to do any sort of development to our API. And with that, Glenn, I think I'll pass it to you to add a little more color around this slide and then walk everyone through the demo.
Great, thanks Adrian, and thanks everyone again. Yeah, so as Adrian said, with FileFly, we took a new approach because we did have a traditional gateway appliance which worked the way that pretty much every other file-to-object appliance gateway works on the market today. And we had that for about, probably about 8 or 9 years actually. So we had it for a long time, and there was a lot of lessons learned we had through there. And we worked out that although it seemed like the right way to do it, for a number of reasons, it just didn't work the way we wanted it to and the way our customers wanted it to. And there was a number of reasons for that. One of them, was just the fact that it was a Linux-based system, and if you wanted services, that was fine. You could use Samba and the NFS. But the problem we found was that a lot of our customers who wanted a filer, they either couldn't manage Linux very well, or if they could manage Linux, they had trouble with the integration between Samba and Active Directory. And because of this, the experience was not very good for them and their users, because you would get mismatches with the rights in Active Directory and out of sync and stuff. So we decided, look, we hear our customers, we hear what we're saying, we believe there's a better way of doing this. So we decided to start from scratch and look at it a different way. And what we realized was, well, if you want a good file server, don't reinvent it. There's great file servers out there. There's NetApp and there's Windows, and Windows is a great file server by itself. So we thought, why don't we enhance these existing file servers to make them object capable and integrate transparently into the object storage, instead of trying to reinvent the wheel and do something, another gateway, which we know because of the issues with active integration, Active Directory integration with, between Linux and Samba and everything, that we're never going to get what people really want, and we wanted something that would scale as well, and scale has been a bit of an issue with the gateways as well. So what we decided to do was we came up with the concept of FileFly. So what we do with FileFly is we enhance existing Windows and NetApp, and how we do that, we provide three different functions with FileFly. The first one is what we call what we do if you're hot data. What we say, if your data is hot and you want primary performance, storage performance of that data to access it for your users, then the best place for it to reside is actually on primary storage. But we still want to protect that, because if you have your data on primary storage, it needs to be backed up, and traditional backup's expensive. It can take a long time to manage every night, to check everything, look at what's going wrong. So we thought, well, first thing that we'll do is we'll give you a system that leaves your hot data on the primary storage, but protects it by making a copy of that data in Koringo Swarm. So if anything happens to it, you can bring it back from Swarm as need be. So that gives us a functionality of what we call our protect of the data for the hot data. The second one is warm data. Over time, the value of your files becomes less as people, don't use them so often. So what happens is, people create a file, they may use it heavily for a day or two, maybe, a week or longer, but normally there's a period of time that file has real value, and after that, people may come back to it in a few months, but you don't want it sitting on your primary storage. So what FileFly does is, using policies that you create, it matches these files, and it moves the data of these files into Swarm, but it leaves the access to the files on your primary storage, on your Windows server or your NetApp. So if your end users or applications want to access them, they continue to do it as they do today. They don't even know that the data no longer resides on your primary storage. And FileFly just brings it back on demand when they need and transparently. And the third function is what we call just the archive, and that is when your data really has very little value. You don't want it on primary storage anymore. You just want it completely on your second tier of Swarm storage, and that is where FileFly will not just move the data and create an object in Swarm, it will actually remove the access from that from the primary storage as well. So you can then continue to access it as an object, and we also provide a tool which allows you to bring the index back if you ever need to onto your primary storage. But generally, if nobody wants the file, then it will just reside in Swarm, and you can find it in Swarm as well, of course, by searching for it and using the web interfaces and stuff. So you can continue to access it through there. So that gives a quick overview of the four main functions of FileFly. And as I spoke already a little bit about it versus the traditional gateways, but the main benefits that you get is the performance, superior performance, because your hot data is residing on your file server. Instead of traditional file gateway needs to continuously bring it back from the object storage and send it back to there. And this can happen many, many times in an hour on the same file. Your users do get a performance bottleneck, and they know that the file is not where it should be anymore. So FileFly removes that. So there's no bottlenecks. There's real performance and easy management because it runs on your existing FileFly. If you know how to manage a Windows server, you can manage FileFly. If you know how to use a NetApp, then you continue to use your NetApp as well. And we will have a look at the policies we can do with the demo, which I think we'll move on to now. So,
okay, I will hand you the presenter. There we go.
Great. So, just give me 1 second. Great. So you should now be able to see my screen. Sorry, just give me a second. I just need to
rearrange my desktop. We can see it.
Great. So what you can see here is we're now connected to a traditional, just a standard Windows 2012 R2 server. And on this server, we have all the components of FileFly running. So we're doing a self-contained server, so you don't need any other infrastructure to run FileFly. FileFly just needs a Caringo object storage, cluster to be able to write to, and that can be through a product of ours called CloudScaler as well. And in fact, this demo is connected to Koringo Swarm via CloudScaler. Now, on this file server, on the D drive here, you'll see that I have a folder, and this folder has been shared out as both CIFS and also as NFS. So you can continue to use CIFS and NFS, and if you wanted to use something like WebDAV with IIS, you can do that as well. It's all fully supported. But if we also look at the general properties of this, what we'll notice is that the size of this folder, the contents of it, is 10.4 gig, and it is also using 10.4 gig of primary storage data. And within there, you'll see that it says there's 45 files and 8 folders. So for the demo, we're going to look at this and see what we can do to remove the amount of primary storage being used. So if I go into this share and I look in there, I see an archives folder. And in this folder, I can see that there's a number of zip and also folders with an extension TEGZ in there. Now, if I look at the properties of this archive folder, I'll see that just this archives folder is using 7.2 gigabytes of the total 10 gigabytes. So now, using FileFly, what we're going to do is we're going to create a policy to move the data of all the zip and TDG files to Swarm transparently. So let's go ahead and do that. So the first thing that we need to do is we need to create a rule. So we'll create a rule, and the rule here we'll call is, we'll just say match zip and TGZ files. And in here we say what we want to match. So we'll stay in this case, we want to match star.zip and star.tgz. So you could add many there, and you can do pattern matching as well. It's quite flexible what you can do. You also have an option you can negate. So if I click negate, now it will match everything other than zip and tgz files. But in this case, we'll leave it normally. And there is a number of other rules that you can set here. These can be based on the size of it, so it could be the minimum or the maximum size. So you may say, well, if a file is this small, then I don't want to move it. Or you could say if it's really big, then I don't want to move it for some reason. But it gives you the flexibility to do these rules. And of course, if you have a rule, if I have .zip and I set a .zip with a minimum size of 1 megabyte, then it would only move zip files that are at least 1 megabyte. But we'll leave that there so it matches all the zip files. We can also do it on a date matching, so we can say of when it was created, modified, when it was last accessed, or when it was archived. So a good one is on accessed. We can say, well, if the file hasn't been accessed for a week or maybe 2 days, then we'll move the data into Swarm because it's no longer hot data, it's now what we'll call warm data. And if we want to do that, we'll do that. But we'll leave this blank as well because we'll just want to match everything at this point. You can do the also the owner of it. So we can say if the file belongs to a certain user, then we want to work on all their files on the files share or the file server. And we can do basic attributes as well. But in this case, we want to keep it simple. So we'll just match our zip and TGZ files. So I'll just save that rule set. The next thing we need to do is to create a policy, and the policy says what we want to do. So what I'm going to do here is I'm going to call this one tier zip and tgz files, and in here we get to choose the operation. Now you'll see there's a number of operations to choose from. Migrate is the one we're going to choose here. So migrate is where we move the contents of the file into Swarm, but we leave an index, a pointer to that file on the primary storage. We could also do one here. There's one called simple pre-migrate, and this is the one which gives you your backup protection. So this is where we create a exact copy of that file in Swarm, but we actually also leave it on the primary storage. Now, every time this policy runs, when you do this backup one, it will only copy files if they have changed, if they've modified since it was last run. If they haven't, then it won't bother about copying them over because it already has the latest copy. But in this case, we'll just select the migrate one. And now what we do, we decide what rule. So we will select our rule match zip and tgz files. I could select more rules if I wanted to, but in this case, we'll just select the one. We decide our source, and you can have as many sources you like. In this case, this is the source on the D drive we just looked at, so I will say I want to work off that one. And we decide where we want to write it to. So in this case, I have a destination set up called My Swarm Storage. So I'm just going to send all the data to there. And the third thing you need to do is create a task. And a task is really, in the Unix world, it's a cron job. It's how often do you want this policy to run. And we'll call this, I'll just call this schedule migrate zip and tgz files, and we'll come down to our policy and we'll select the one which I just created with a bit of a typo in there, but we know that's the one we want. And we decide when we want it to run. So if I wanted to, if I did this, then it would run continuously, so it would always be running, but I can have a lot more flexibility than that. So I could say, well, actually, I wanted to run it 5 minutes past 10 o'clock every night. Or I might say, well, I wanted to run only Monday to Saturdays at that time. Or I could say, well, actually, I just wanted to run maybe on the 31st of December every year, so I could run it once a year. But in this case, we are just doing the demo, so we'll just save that now. And we now have everything we need to move that data. So if I go into the schedule we just created, and there's a little button here, Run Now. So we'll run it straight away. And we do that, and it will be running away. And we can see that it's running here right now. And we can see that it's going through and it's finding data to move. If we give it a bit, it shouldn't take very much longer. There we are, and it's finished now. So if we have a look at that, what it did, it moved 9 files which totaled 7.27 gigabyte, which nicely matches what we saw before for the archives directory. So if I now have a look at the archives folder itself, what I'll see is before, where it was using 7.27 gigabytes on disk, it's now only using 3 kilobytes, although it still reports as for the size as being 7 gigabytes, so you know how much is there. So if I go back one and I look at my share as well, I'll see the same. So I will see now that the size on disk has dropped from 10.4 down to 3.13 gigabytes. So what happens if I look in the archives directory now? Well, if I look in there, everything looks the same as it did before. All the files are still showing as their correct size and everything there. So as a user, it all looks fine. But if I look inside of one of these files at the properties, what I'll see is although that the file itself is 815 megabytes, it is now using no storage at all. So it's using no primary storage. So there is really just an index there. And now if we look at another one here, and we can see the same. So this one was only 3.74 megabytes, but again, it's now using no primary storage at all. So what happens if I try to open one? If I double click on one, and what I can see is it's come through, and if I go into it, and I can now open up one of these files on it, and as you can see, I could access it straight away, and as an end user, I wouldn't have even known that that data had now been moved back off Swarm to be sent to me. So it's just completely transparent to your users. So what we'll do now is we'll just run one other policy very quickly. So if we look at this now, we use install 10 gigabytes reported, and we're now only using 3 gigabytes of primary storage, but we'll remove that a little bit more. So we'll actually run a job, a task which is already here, and we have one here which is this one here, which is scheduled 10 p.m. daily smart tier all files except databases. Now, if we quickly look at the policy for this one, which is this one here, what we'll see is that this one here, oh, sorry, we need to look at the rule. Sorry, I wanted to look at the rule. So if I have a look at the rule here, what we'll see is this rule is a combination of two rules. It's a combination of all files and not databases. So the all files says match everything, and not databases says do not match anything starting with star.db. And so by doing this, what I can do is move the data for everything other than databases. And the reason you may want to do this is your databases are always active generally, and if they're always active, you don't want to move them into your primary storage. And this is something unique with FileFly. With your file to object storage gateways can't do this. So with a traditional gateway, you can't have data you do not want to move on the same file server. You need to put it on. You need to now have different file servers for different types of data with a traditional gateway, because if you had your databases on a traditional file to object gateway, it would always be trying to send that data off to Swarm or off to the object store. So FileFly doesn't. It does. We don't even want to move it, so we don't. And FileFly is bright enough to know that you have mixed case of data on there. So I'm just going to quickly run that schedule right now, and if we have a look, it's running through and it's already finished. So if I have a look again, this time it moved another 2.5 gigabytes of data, and if I quickly have a look in here at the properties again, I can now see again that we're now using only 600 megabytes of primary storage, whereas previously we were using 10 gigabytes. And actually, just to make sure that it is with the databases, if we look at the databases folder, we'll see that it does match the 632 megabytes. So that policy, we have moved some data, but not everything. We've left what we want to stay on primary storage, but we've moved it off, and we've freed up, over 90% of our primary storage just there. So the last thing we'll quickly look at is what we call the protection, and we'll do this very quickly, but if I go into this folder here, we'll see some documents, and we'll see in here one called a FileFly demo doc. If I just bring that up quickly, we'll see in here that the version is shown as version 1. So I'm just going to change this to version 2. Oops. Do that again, and I will just save that. So let's save. Now, just to be sure, let's just open it up again. And what we'll see is we're now got version 2 in here. So actually, what I'm going to do now is I am just going to delete this. So it's gone now. Now, I deleted that by accident, and I want to bring it back. So what I can use is something we have in here called the DR tool. And using the DR tool, what I will do is I'll just bring back that file that I just deleted. Sorry, I might want to filter on it because it will show me everything. Let's just have a look at everything starting with an A. And we've got this one here. So using this tool, I will just recover the index to that file that I deleted before, and we'll say yes. And what we can see is it now again shows in my directly folder listing. And if I open it up, what I can see is I got my version 1 back, which was the original version before I deleted it. So what I've just done there is given a very quick overview demo of Caringo FileFly and how it can be used to both protect data and also reduce your primary storage. So in this case, I moved 90% or over 90% of the data off my primary storage into Swarm, which again, gives me a huge cost saving when instead of needing to continuously add capacity to my primary storage using FileFly, I can leave my primary storage as it is but move data off. So my existing asset of primary storage can be reused for more data and files.
So that was a great demo. Thank you, Glenn. Now we'll open it up for questions, Q&A. As Glenn showed, we're able to move 90% of the information from primary storage to object storage by our calculations, taking the most conservative price of NetApp filers on the market. We got a 4 times cost savings compared to primary storage when looking at Swarm on commodity storage or standard hardware on standard hardware. And I say conservative because there are some primary storage technologies that are much more expensive, but that's where you got the save 4 times in your TCO in 30 minutes, and Glenn showed you how to do that. Once your data is on Swarm, you could then, it's consolidated on one platform and you can analyze it, so you get a lot of additional benefits other than just cost savings.